Alright, so we want to find the equations for lines that are tangent and normal to the graph of f of x equals tan x over x when x is equal to 2. What does that mean if we're going to find lines that are tangent or normal? All that means is we've got to have a derivative, and we need a point, and if we have a derivative and a point, we have a slope. So let's go ahead and try and figure out what the derivative of this guy is. We're going to have to use the quotient rule. So f prime of x. And when we do this, we need to know what the derivative of tangent is. What's the derivative of tangent? And that's going to be secant squared x. So I'm going to have low d high minus high d low all over low. Okay? And on the top, I'm going to end up with x secant squared x minus tan x over x squared. This is my derivative of my original function. And so I can also find the slope. Where am I interested at slope on this particular guy? I'm interested at slope when x equals 2. So in your calculator now, you're going to have to do a little bit of work. And what we're going to do is we're going to put a 2 in to all of these different places. Okay? And what we're going to find is that our y value, not our y value, our slope in this case, our slope is going to be 3.43. All right, and that's okay. We can have that. It's not a problem at all, and we're dealing with the trig function too, so that's probably going to give us a decimal anyway. So what does that mean though? Well, I need to know a point that is on my curve. Okay, and so when you put your 2 in for x into your original function, you would have the point tangent 2 over 2. And so if I'm going to write the point slope form of that, so when you punch that into your calculator, the decimal form of that would be 2, and then the y coordinate would be negative 1.09. 2 or 3, depending on how you round. So my tangent, we'll write tangent in purple. My tangent line is going to be y minus the y coordinate equals the slope times x minus the x coordinate. And this is a good answer. You don't have to do anything else here. It's a point slope form of a line. I'm happy. Remember, with normal, that's going to be the perpendicular. That's going to be perpendicular to the slope. So that's going to be the opposite reciprocal. So when I look at the opposite reciprocal, I get 0.291. So our normal then is going to be y plus 1, 0.093 equals 0.29, negative 0.29, x minus 2. So there's how you can find the tangent and the normal using your trig functions and derivatives. It's no different than how we were doing it before. It just may have a little more decimal action going on. Okay. What about if we wanted to find the second derivative though of secant? Second derivative of secant. Well, we just dive right on in. We need the first derivative. So the first derivative of secant is secant x tan x. And then once you get here, you've got u and you've got v. So I need the derivative of u prime. Well, we just talked about that. Derivative of secant x is secant x tan x. And we need the derivative of v. So when you look at the tangent, the derivative of the tangent is secant squared. Secant squared x. So we're going to go with the first times the derivative of the second. So we're going to have secant x, and this is going to be y double prime here. We're going to have the first secant x times the derivative of the second, secant x tan x, plus the second, which is just going to be tan x, up. I've gone wacky here. The first, which is secant x, times the derivative of the second, which is secant squared x, plus the second, which is tan x, times the derivative of the first, which is secant x tan x. Okay? And so when you simplify this all the way down, you're going to end up with secant cubed x plus tan squared x secant x. And this is a good answer. You don't need to stress yourself out and try and simplify that down a lot more either. So there you go, some examples of trig functions and how to use them. Looking also at previous examples, which included jerk, and how to derive some of these things in simple harmonic motion. A lot of stuff going on here, so make sure you've got good notes that you could go back and refer to. Make sure you ask questions or send a tweet to @HazelwoodMath.